Hello folks, this is the first of a two-part series that's going to look at ratios and proportions. Today we're going to go over ratios. We'll go over proportions tomorrow. I'm going to set the ground for that. So what is a ratio? Well, a ratio is a means of comparing two unrelated things using numbers. And we'll look at a couple examples of that in a little bit because I know that sounds very abstract. We can write ratios different ways, three different ways actually. You can see them written like this, 2 to 1 with a little colon in between our two numbers. We could write it 2 to 1 and spell out the 2, or you could write 2 to 1 with the 2 over the 1. Either of these ways is acceptable. Either of these ways will get you credit on the homework. I think everything in the homework is programmed for you to answer 2 to 1 or 2 to 1, one of those. But any of these are okay. A note about this guy right here, he is a fraction, right? He's written like a fraction, just like everything that you have just finished up in your fractions lectures. Ratios can be written as fractions, they can be treated as fractions, but they are not true fractions. And the reason for that is because we can have decimals in our ratios, we can have fractions in our ratios, though generally you don't want to. The other reason for that is because we always want to have two numbers in our ratio. This guy right here, 2 to 1, or 2 over 1, if this was a regular fractions assignment, 2 to 1 you would write as just 2 for your final answer. But that's not the answer that we're looking for in our ratios homework, because a ratio, again, has to have two numbers. So we would keep him as 2 to 1. This also means that when you're doing your homework and you finish and you get an answer like this, 11 to 5, that would normally be an improper fraction. You will not change your improper fractions to mixed numbers. There are no mixed numbers in ratios. So hopefully some of you are breathing a sigh of relief, because that's one less thing that you have to do with your answer when you're done. Improper fractions are perfectly fine here as ratios. So two unrelated things using numbers. What does that even mean? What does that look like? In reality, you use ratios a lot in everyday life. For example, here's our medical crew. We have one patient. Hopefully she's doing okay. To 3, nurses. Everyone looks very happy, so she's probably okay. They're probably not going to cardiovert her. Here we have our vet tech, who's very happy with 2 cute fluffy puppies. So we have 1 tech to 2 puppies, which is an excellent ratio because that's also how many hands you have. Looking more practically, we see ratios a lot in the medical field when we deal with medication. And we will talk about this when we get to proportions because good use of proportions, the techniques that we'll talk about in proportions, is crucial for being able to convert medications when you need dosages. So for example, this is lorazepam. Also called Ativan. You use this when you're having a bad night. Lorazepam, this liquid suspension that we have, comes 2 mg to milliliter, which is a ratio. For every 1 milliliter of the medication that you draw up to give to your patient, or maybe yourself, for every 1 milliliter you draw up, you have 2 milligrams of the medication in there. This is dexamethasone. It's a steroid. Actually just had a very good study come out looking at the use of DEXA treating COVID. Dexamethasone comes in 2 milligram tablets. That's a ratio as well. And probably you're saying, but wait, Ms. Catherine, that's only one number. And that's true, it is only one number. But this is 2 milligrams in a tablet, right? Each one of these little white tablets is 2 mgs. So we could write that as a ratio, 2 milligrams to 1 tablet. Now, it doesn't matter how you write these ratios. I could have written 1 tablet over 2 mgs. Either one of those would have been acceptable, or 1 milliliter over 2 milligrams. I do strongly recommend making sure that you pay attention to your labels. What we have here, milligrams, milliliters, tablets, those are going to be very, very important when we get to our proportions and when we start talking about converting, when we start talking about converting back and forth in proportions and doing dosage conversions. Now, because we can write ratios like a fraction, we can also treat them like a fraction, which means that we can reduce ratios. Let's say you've got this guy, 250 to 100. We can write that as a fraction. That would be 250, the first number goes on top, over 100. And then we can reduce this the same way that we would reduce a fraction. So this is all of that fractions 1 and fractions 2 lectures have now come back to haunt you. You'll never escape from them. So 250 over 100, we can divide this. We could reduce, let's say by 50. 50 will go into both of those numbers. 250 divided by 50 is 5, because 25 divided by 5 is 5. 100 divided by 50 is 2. So here's our final answer, 5 over 2. And again, hopefully if you paid good attention to the ratios lecture, you're looking at that and saying, wait, that's improper. And that's perfectly fine. Improper fractions are good in ratios. Right? We would never convert this to 2.5. 2.5 is not a ratio. We want to keep it 5 to 2. So if there's one less step that you have to do in your homework. How about this guy, 39 to 13? Again, write these as fractions. When you're reducing them, it's going to be a lot simpler for you. So first number goes on top, so 39 over 13. What can we divide this by to reduce this ratio and make it smaller? Well, we can divide it by 13. It's the only thing we can divide it by because 13 only divides by 13. So 39 divided by 13 is 3. 13 divided by 13 is 1. So our final answer is you could write it 3 to 1 like that. You could write 3 to 1. You could write 3 to 1. And any of these would be acceptable ways to write your ratio. The way that would not be acceptable is if you simply told me 3. That's not acceptable because, again, ratios have to have 2 numbers. We have to have that 1 in there for our proper answer. Okay, what if we stick some fractions in our ratios? Oh dear heavens, they never end. These can also be reduced, and we want to reduce them. We don't want fractions in our ratios, generally speaking. We like to have them reduced down to nice, pretty whole numbers that are easier to work with. Now, reducing a ratio that has 2 fractions in it is actually a lot simpler than you probably would think at first glance. This little colon right here in between our 3/4 and our 2/5, we're just going to put a little line in there, and all of a sudden it's magically a division sign. So in order to reduce ratios that have 2 fractions, you will divide them. So we'll do 3/4 divided by 2/5, and hopefully you remember copy dot flop from the fractions part 2 lecture. We copy the first fraction, 3/4, dot, we change the division sign to multiplication, and then for flop, we flip the second fraction upside down on his head. So now instead of 2/5, we have 5 over 2. Now we multiply. 3 times 5 is 15. 4 times 2 is 8. And that's our final answer. That's our reduced ratio. So now instead of 3/4 to 2/5, we have 15 to 8. And again, you could write it like a fraction. You could write it 15 to 8. You could write it 15 to 8. Either of those would be acceptable. Let's look at another example. Here we have 5/3 to 5/8. Go ahead, pause the video, try this on your own, do your division, and then come back and we'll take a look. So again, turn your colon into a division sign, line in there. And now we'll divide, copy dot flop. So copy the first fraction, 5 over 3. The division turns into multiplication, copy dot, and then flop. 5 over 8 becomes 8 over 5. And now multiply. 5 times 8 is 40. 5 times 3 is 15. Okay, we don't have any more fractions in our ratio. Can we reduce our answer, 40 over 15? Will that reduce down any smaller? It will. If you look at the two numbers that we multiplied to get 40 by 15, they both have 5 in them. So we know we can divide this by 5. 40 divided by 5 is 8. 15 divided by 5 is 3. So our final answer is 823. And again, he is improper, and we will keep him an improper fraction. Do not convert this to 6 2/3. Okay, let's go one better. What if we have mixed numbers? What do you think we're going to do here? Our rules for mixed numbers are going to be just the same as our rules for dividing with fractions. So remember in the lecture when we talked about dividing fractions, whenever you divide or multiply fractions, you always have to turn your mixed number into an improper fraction. Same thing here. So first things first, our mixed numbers are going to become improper. So 2 1/2, hopefully you remember how to go from a mixed number to an improper fraction. We do the denominator times the numerator, or denominator times the whole number, sorry. So 2 times 2 is 4. Add your numerator, which is 5, so 5 over 2. And then here, 3 1/2. So 2 times 3 is 6. 6 plus 1 is 7, all over 2. And now from here, turn that little colon into a division sign and divide. 5 over 2 times 2 over 7. 5 times 2 is 10. 2 times 7 is 14. And then we can reduce this. We can divide 10 over 14 by 2 and reduce it down to 5 over 7, or 5 to 7, I should say. And that's your final answer. Make sure that you do this first. True about any multiplication or division with fractions. How about one last example? Now, instead of fractions, we have decimals. Oh dear heavens, what do we do? The best thing to do here is to convert your decimals into fractions, because then you can do your copy dot flop pretty easily. Hopefully you remember how to go back and forth from decimals and fractions from the decimals lecture. So 0.05 or 5/100ths, remember everything to the right of the decimal is your numerator. And then the place value of the last number in the decimal is your denominator. Same thing with our 15/100ths. Everything to the right of the decimal is your numerator. The place value of the last number, that 5 is in the hundredths place, so our denominator is 100. Now that we have our two decimals converted, now we can go ahead and divide. So copy dot flop. 5 times 100 is 500. 15 times 100 is 1500 or 1500. And we can reduce this answer. Both of these multiplied by 100. Actually, both of these multiplied by 100 and by a multiple of 5. We can divide both of these by 500. So 500 divided by 500 is 1. 1500 divided by 500 is 3. So our final answer is 1, 2, 3. Or 1, 2, 3. Either of those. So that is most of what you'll be looking at during the homework for this section of the math class. You will see this all come back to haunt you tomorrow when we talk about proportions. So make sure you're very comfortable with this. If dividing fractions makes you uncomfortable or nervous, or you're not comfortable converting decimals into fractions, please come see me during office hours or send me an email so we can go over it together.